So, ladies and gentlemen, we're going to do a very quick review of multiplying polynomials because we got to find the area of figures, but eventually to 3 dimensions, and we're going to start with 2 dimensions. So I'm going to assume you have your formula sheet easy to get to for this chapter from 5. I believe it was the second day of the assignment. So we're going to review how to multiply these and then find the area. So one thing to remember is when you multiply variables, there's a hidden 1 on top of this. So what we do is we end up actually distributing. Now I'm going to show every step here. So what we're really doing is x1 times x1, and we're going to do minus x1 times 5. Now this is not work I would expect you to show, but when you multiply variables, you add the exponent. So 1 plus 1, this would be x squared. And then we bring down the minus, and this would be 5x to the 1. We cannot combine these. So we would just have your final answer is x squared minus 5x. We don't need the 1. And this would be what you would do. Now the next type of problem you guys would have done would be what we would call FOIL. So remember your hidden 1s, and there's a hidden 1 in the front, but the first thing we would do is x1 times x1, which would give you x squared. Then we would do the outer, which really is going to be a plus x1 times 3, which would give us 3x to the 1. Then we do the inner. We would have plus 4 times x to the 1, which would give us 4x to the 1. And then we would have 4 times 3, which would be 12. These have the same exponents, so we can combine them. So this would be 7x to the 1. Bring down the x squared. Bring down the 12. And to clean this up, we really don't need the 1, so this would be x squared plus 7x plus 12. You can keep the 1 if you want to, but it's fine not to have it. So on this problem, we're doing the same thing. We're going to distribute here. So we would have x squared times x to the 3rd, but the reminder is you add when you do exponents. So this would be x to the 5th power. We'll do this next piece next, so it would be a minus x squared times 5, which would be 5x squared. Inner, so we'd have plus 3x cubed, which is just plus 3x cubed. And then a positive and a negative, this would end up being minus 3 times 5, which would be minus 15. And to put this in standard form, because nothing's alike, we'd have x to the 5th plus 3x cubed minus 5x squared minus 15. So so that's the first type of problem. Now we're going to do exponents. Now the rule is if there's an exponent on the outside, it distributes to both numbers. So we would have 6 to the 4th and x to the 4th. So just grab my calculator, figure out what 6 to the 4th is. I said I'll figure out what 6 to the 4th is. So this would be 1,296 x raised to the 4th power. So you always do the exponents first. So since I like examples in pairs a lot, this one would end up being 3 to the 4th x to the 4th. And really, you're supposed to do them in parentheses with the power. That might become important later. So 3 to the 4th, typed in, I believe is 81. Yep, 81 x to the 4th. Which leads us to the trick question. When you're doing this problem here, 3x times 5x squared, there's a hidden 1 with these x's, but you do not multiply the 3 first. We will do this piece first. So we would have 5 squared x squared. So this piece turns into 25x squared, and then we drop the 3x down with that hidden 1. The issue is you're supposed to do exponents first, then multiply. Well, now we'll multiply these together. 3 times 25 is 75, and 1 plus 2 is 3. And that's our final answer to that question. So now we get to the weird ones where I'm asking you to keep your answers in terms of pi if needed. It's pretty much, you kind of pretend the pi is not there. We do the same thing again. We will multiply the 5 first, but we'll have 5 squared x squared, but we don't care about the 3 pi. And this would turn into 25x squared, and then we drop the 3 and pi. So pretty much to keep things in terms of pi, you pretend the pi is just a variable, even though it's not. 3 times 25 is 75. But now we'll attach the pi and then put the x squared this way. This is what it means to keep an answer in quote-unquote terms of pi. And last, we will do a review of this one, just about the same problem. Since this ends up being the same piece, this would be 25x squared because it's exactly the same as this piece here. And then we drop the 2 pi. And to keep it in terms of pi, we do 2 times 25 is 50. Leave the pi, and then write the x squared down. Okay, so guys, that's a review of some old stuff. So now do the first set of homework problems, and then come back and look at the second video.